Alright, so in today's lesson, the second chapter of differentiation, we're going to look at more examples on how to solve these questions, differentiating from the first principles. So here we say that this is what we looked at previously. Okay, so we can have a refresh, or rather a recap of what we had. We said if you have been given a function y equal to let's say we have 4x x there, we say it's squared plus 1. Okay, if you have something like that, we said the first thing we do, we have to use the formula. In our formula we said it is f prime of x equal to the limit as h approaches 0 then you say f of x plus h minus f of x, everything over h. So you say this f of x there, f prime of x, we can also say this is y dx. We can also say this is what y prime. So it doesn't really matter what we use here. So in this case we are going to say our dy dx is equal to the limit as h approaches 0. So we are going to get this 4 which is in front of that, this one. We shall say okay, this is 4, then we open the bracket, then we write this part. So we're going to say x plus h, then we check the degree of this term. So since it's squared, we're also going to square there. Okay, then we say plus 1, then minus the whole lot of this function that we have been given, this. So open bracket for x squared plus 1. So this will be everything divided by h. Okay, sorry for that. We are saying we bring the 4 there, then open x plus h, then squared since the function is to the power 2, then we say plus 1, then minus the whole lot of the function in bracket 4x squared plus 1, then we introduce that, then we say everything divided by h. So the limit is going to be h approaching 0. This is going to be 4. When you expand this part, you are going to get x squared plus 2hx plus h squared plus 1 minus 4x squared minus 1. Everything divided by what? Everything divided by h. So the limit here is going to be limit as h approaches 0. This is going to be 4x squared plus 8hx plus 4h squared plus 1 minus 4x squared minus 1. Everything divided by h. Then we can now say okay, since we are done there, we can cancel out now the terms that are similar. if we check, we have this 4x, okay, and that negative 4x. Those two terms can cancel each other. If you also check, we have got this positive 1 there and the negative 1 there. So what we are going to do is this will cancel with that one, then this one will cancel with that one. So at the end of the day, we are going to remain with 8hx plus 4h squared. Everything divided by what? Everything divided by h. So here we're going to say the next thing, we're going to factorize h there. So in factorize h, we're going to say, okay, hopefully you guys are able to see that we have this h is common there. So we're saying when you factor out h there from 8hx, we're going to remain with 8x plus 4h. Then we close everything divided by h like that. So now this and that can cancel, and our answer will be 8x plus 4h. But we said that when h is 0 here, if it approaches 0, so this means that this 8x plus where there is h there, we multiply by 0. 4 times 0, it will just be 0. So this part will just remain with it. We just remain with 8x as our final answer. So that is what we did yesterday. So some quick pointers. Just make sure that your formula is properly written. I don't know, it was a typo yesterday where we had to say this was x, but no, that's the wrong definition. That's the wrong definition. So we are saying it is h, it's the limit as h approaches 0, because it's the one that we are interested much in. If you take a look at our equation in the first place. Okay, so yeah, this is what you need to know about the first principle. Let's now look at some more interesting questions. Okay, so if you find some more interesting questions that you failed to solve, please send them as soon as possible so that we move together. Alright, so now let's look at something interesting for today. So we look at something interesting for today. So the first question that we're going to have is this one. Okay, the function f of x is given by the root of, okay, it's given by it's given by the root of what? It's given by the root of 2x minus 1. Okay, so we are differentiating that one from the first principle. So as we always do, we're going to say f prime of x as the limit h approaches 0. This will be fx plus h minus f of x, everything divided by h. So the derivative will be the limit as h approaches 0. So this will be here we have this 2x minus 1. So we are going to add h to this. So when we add h from according to the formula, it's going to be 2x plus h then minus 1, like that. But this one we can simplify it and work with something like this. We're going to say this is 2x plus 2h minus 1. It's one and the same thing. So we are going to work with this and note that. So let's write that. So I'm saying we have 2x plus 2h minus 1, everything, our function minus what? This is 2x minus 1 dividing, okay, sorry for that, so everything dividing what? Dividing h. So this is very simple. One thing we are going to do is the easiest we are going to do, or rather this is what we're going to do always. If we have got radicals on top there, we are going to introduce the conjugate of these of the numerator there, of those radicals. So we are simply going to say, okay, the limit, or rather f prime is going to be equal to the limit as h approaches 0. So this is 2x plus 2h minus 1 minus 2x minus 1. So this will just be divided by h. So we are going to multiply this by the conjugate. So this is going to be 2x plus 2h minus 1. Then since it's minus here, we're going to say plus the root of 2x minus 1, which is this part here. Then everything dividing by what? Dividing by the same conjugate. So which is 2x plus 2h minus 1 plus 2x, like that. So this limit is going to be the limit as h approaches 0. So here we are not so hopefully we did well with the radical versus conjugates. When we multiply this and that, the radicals will cancel each other, and now since everything that is inside is the same, when you're multiplying 2, the root of 2 and 2 like that, you just remain with the answer 2. So you just get the top, the inside part. So equally, even here we're just going to get the inside part. So this is going to be 2x plus 2h minus 1. Then from there we can expand this one. Let's just a minute. So when you multiply this by that, and then you are also going to multiply this and that, what you are going to get is a 0. So if you want to waste time, you can multiply it. I'm saying this and that, and then you multiply this and that, you're going to get a 0. So even if just work out this one, those that are identical, this one, this part, and also that, then also this part and that part. So multiply this with that, then this guy, with that one. So we are now going to say, okay, what we are remaining with is so now we can multiply that. So we are remaining with negative 2x minus 1, which is everything that we are dividing by. It's going to give us h multiplying 2x plus 2h minus 1 plus 2x minus 1. So the limit here as h approach 0 will be 2x plus 2h minus 1 minus 2x plus 1 when you expand the top part. Okay, so after you expand, we can even simplify. We can even simplify that. This is going to be this part 2x and this one will cancel out. Then we also see that this one and this one will also cancel out, so we are just going to remain with the 2h. So what remain with here is 2h, everything divided by this. Okay, so we're going to say we have h multiplied by the conjugate of 2x plus 2h minus 1 plus 2x minus 1. So this will be 2. Why? Because this and that will cancel out. Then we are going to remain with 2x plus h, or rather 2h minus 1 plus 2x minus 1. So now create space, create some space. Okay, so we can work with that now. So we are saying this is 2 over the root of 2x plus 2h minus 1, everything plus 2x minus 1, like that. So when we put the 0 where there is 2h here, this will be 0. So the final answer, this is just going to be 2 over 2x minus 1 plus 2x minus 1 in the square root. Then you know that 2x minus 1 plus 2x minus 1 would just be 2x minus 1 in the root. So the final answer is going to be 2, then 2 root over 2x minus 1. Then these 2 and these 2 can cancel out, so that you just remain with 1 over the root over 2x minus 1, and this will be the final answer. Okay, so hopefully that one is just okay. So we need to practice on that. We need to practice on that. Let me know where it will give us a problem. So quickly, let's go to the next question of the day. Alright, so the next question we're going to do is also very interesting. In this question we are saying the function f of x is equal to x minus 1 over x plus 1. We are differentiating that one from the first principle. So this is what we're going to do. The formula f prime is equal to the limit as h approaches 0 f x plus h minus f of x, everything divided by h. So this is going to be f prime of x is going to be equal to, so we have x minus 1, so I'm going to say x plus h according to the formula, then minus 1, then everything divided by, even the down part we're going to say x plus h, then plus what? Plus 1. Then this minus the function itself, which is this same thing. So I'm going to say minus x minus 1 over x plus 1. So this is just going to be no, we are saying everything divide by h. So when you divide by h there, we shall get f prime of that as the limit of h approaches 0. So we are going to work out the top part. So we shall work out this. Okay, we have to make it in a single fraction if it's like that. So remember, if we have radicals, we have to introduce the conjugate. If we have got something like this, we're going first to do what? We're going to make this as a single fraction. So making that one as a single fraction, it will just be x plus h minus 1 over x plus h plus 1 minus x minus 1 over x plus 1. So this will be x plus h plus 1 x plus 1. So on top we are saying this one will multiply with this thing, so plus 1 x plus h minus 1 minus x minus 1 multiplying x plus h plus 1, like that. In the final expression there, okay, the final expression we are going to have, after we do that, we are going to have x squared, then plus hx minus x plus x plus h minus 1 minus x squared, okay, plus x plus x there, then you're saying minus hx plus h minus x plus 1. Okay, hopefully we are just okay with that one. Hopefully I've not missed it. So everything dividing this part, everything divided by this part. So we're saying we have x plus h plus 1 in bracket x plus 1. So everything divided by h. So now this is what happens when you have something like that. So you're just going to bring this this down part, this one, just multiply it with h there without wasting much of your time. Don't start doing when you since you have, because I know someone will start thinking like this. We have 1 over 2 divided by 3. No, because I should do 1 over this, then I introduce that, then I say this, that 1 over 2, then times this, so that this one, that is a sheer waste of time. You don't have time for that in the exam. So just bring this thing in the blue, in the blue color, just multiply with the down part there. And what I mean is this, the down part is going to be, it's just going to be h multiplying by this thing in blue, which is x plus h plus 1 multiplying x plus 1, like that. That is what I mean. So every time you have something like that, just bring it down. So now the next thing we're going to do is we're going to identify things that are common in here and cancel them out. So if we take a clear close look at those things, we have x there and x, so these two will cancel. We have this and that, they will cancel. We have this, it will cancel with that one. Then we have this negative 1, it will cancel with that positive 1. Then we have this x, it will cancel with that x. So on top we're going to remain with h plus h, which is just 2h. So we are saying we are remaining with 2h like that. Okay, so at this point now we have to know that, okay, since there is this and this, there is h on top and h down like that, we can cancel out these two. So this h and that one can cancel out. So this is what we are going to remain with. We shall now remain with 2 over. So now here we are saying where there is h we put a 0, so it will be x plus 0 plus 2 plus 1, I mean, which will just be x plus 1, then close bracket x plus 1. So if we want, we can even say this is 2 over x plus 1 squared, because we have got 2 of those things. So this is our final answer. Hopefully you had followed. These are typical exam related questions. So if you have a problem, kindly get back to me as soon as possible. Utegwa tuendera ntomwe. So let's look at some other question, which might be the last question for tonight. Okay. So the next question is okay. So they are telling us that the function that over the root of x plus 2. So we are differentiating that one from the first principle. We are differentiating from the first principle. So this is what we are going to do. First step, as always, formula. So f prime is equal to the limit as h approaches 0, f plus h there minus f of x, everything divided by h. So this is going to be f prime of x as the limit h approaches 0. This will be 1 over, so this you are going to say it is x plus h plus 2. Then you can now subtract the same function, say 1 minus 1 over the same thing that you had here. Okay, so x plus 2. So the whole lot of this is divided by h. So now you have two fractions on top. You have two fractions. So like we did in the previous example, we are going to do what? We are going to make them a single fraction. So making this one a single fraction is just going to be 1 over the root of x plus h plus 2 minus 1 over the root of x plus 2, which will just turn out to be you are going to have that as your common denominator plus 2, then this x plus 2. So here you are going to get x plus 2 minus x plus h plus 2. So this is what you are going to substitute for the upper part, or rather the numerator. So we are now saying, okay, this is going to be equal to the limit at h approaches 0. So the upper part we are saying we are going to put x plus 2 minus x plus h plus 2, everything divided by the common denominator, which was x plus h plus 2, then x plus 2. Okay, then we know that everything is being divided by what? By h. So what are we going to do? Remember what we said here. You have got a fraction that is of this form, 1 over 5 divided by 3. So we said that just get this part 5 and multiply it with 3. So this is how this one turns out. You're just going to say this is 1 divided by 5 times 3, which is just 1 over 15. So equally here you're just going to bring this part, you multiply with the h. So we are going to say the limit here as h approaches 0, this is you are going to, on top you are going to remain with x plus 2 minus x plus h plus 2, everything divided by h only, x plus h plus 2. Okay, multiplying x plus 2. Okay, so the next thing you are going to do, So remember what we did in this in the first example for the radical functions. We introduced the conjugate. Since you have got this x plus 2, these are conjugate, these are radicals, so we have to get rid of them. And how do we do that? We are going to introduce the conjugates for that. So this is what we're going to do. We're going to say this thing is multiplying what? It's multiplying by x plus 2, then minus or rather plus x plus h plus 2, everything divided by the same thing, x plus 2 plus x plus h plus 2. So here now we are going to say the limit as h approaches 0. So when you work out the conjugates, you are saying this times this is that is what you're interested in. So you are going to get x plus 2. Then you don't multiply this times that. You don't multiply this part and that part, because you are also going to multiply this and that. So the green ones plus the brown ones, they will just give you a 0. So just multiply this, sorry, just a minute. So just multiply the likes, this one and that one. Then after you're done, multiply this and that. So now this is basically what I've done. I've multiplied the first part, x plus 2 in the square root, multiplied by x plus 2 in the square root to just give us x plus 2. Then we're going to multiply x plus h plus 2 with the x plus h plus 2 to give us negative that, because there's a negative in front here. So it's going to be negative x minus h minus 2, everything dividing everything by h on x plus h plus 2, then x plus 2, which will now just give you. At this point you can also check if there is something that cancels. So this and that can cancel, positive 2 and negative 2 can cancel, so I'm just going to remain with negative h there. So I'm going to say negative h over h open bracket the square root of x plus h plus 2, then x plus 2. So this one and that one can cancel, so I'm going to remain with negative 1 over the root of x plus h plus 2, everything multiplying by x plus 2. So when you put a 0 there, you are going to say this is just x plus 2. So basically what you are going to get as your final answer here is you are going to get negative 1 over the root of x plus 2. Okay. Is it? Yeah. So like that, x plus 2. So you can end here. That will be the final answer for that problem. Okay, so hopefully you found this one helpful, and hopefully there are no things that have been left hanging, sorted out issues. Okay, so this is about differentiation from the first principles. I'm sure from now we can solve a good number of questions. Otherwise, thank you so much for your attention. Watch out for the next lesson. Okay.